Okay, optimization video part 7. Suppose we have a right triangle, and we have in this right triangle we need to find the maximum area of this triangle if the sum of the legs is 18 meters or centimeters. So this is 90 degrees. This is hypotenuse, right? The side faces 90 degrees, and the sum of these two legs is 18 centimeters. Great. We need to maximize the area. We need to find the maximum area of this triangle. Let's say one of the legs is x. What is the other length will be? 18 minus x, right? Because x plus 18 minus x will be equal to 18 centimeters, right? This means if one of them is x, the other is x minus 18 minus x. And what is the area of triangle? Area of triangle is half base times height, right? Which is, if we consider that 18 minus x is the base, so x will be its height. Let's see. Half times 18 times x, it's 9x. Minus half times x is half x squared. This is the area of triangle. How much will be the side of triangle? The side of triangle, how much will be this side specifically, which is x, right? It's between 0 and 18. Because if it is 0, area will be 0. This means we don't have triangle, right? Area of 0 is 0. And area of 18, also if we substitute 18 instead of x, we're also going to get 0. So in this case, x should be a value. If we take it 0, that will not work. If we take it 18, that will not work. And this will be a value between 0 and 18. And to do so, we should find the derivative of this area. And that is equal 9 minus x, right? It's 9 minus x. When the derivative is equal to 0, this means 9 minus x is equal to 0. That gives me that x is equal to 9. All right? And this will work for sure, because if we find the area when x is equal to 9, this will be half into 18 minus 9 times 9. So the answer will be, this is 9 times 9, 81 divided by 2. Therefore, the maximum area of the triangle is, 18 divided by 2. Area is 81, divided by 2. That is 81 divided by 2. It's 40.5 centimeter square. And that's done. Let's see another example. Let's go for another problem. Another optimization problem. Suppose we have abscissa axis and ordinate axis, right? X-axis and y-axis. And suppose we have a parabola. Here. Let's draw this. Suppose we have a parabola. Okay, let me just put this maximum point of this parabola, and let's draw this parabola from here to here. Okay, suppose we have a parabola. Okay, this is the network. All right, suppose we have, let me see the problem. Let f of x be the area of a rectangle under the curve y equal minus x squared plus 1. So the rectangle is under this curve. Let's draw under this curve a rectangle. Okay, and suppose the area of this rectangle is f of x, right? The area of rectangle f of x is the area of the rectangle, which is under this parabola. The rectangle under this parabola with vertices, right? Minus x0 and x0. We have those vertices, two of the vertices of this rectangle, and we have that 0 less than or equal x less than or equal 1. Okay, first we have to find f of half. That's great. To find f of half means we have to find first the area of rectangle, because f of x represents this area, right? F of x represents this area. So let me find the area of the rectangle. First, what is the width of the rectangle? What is the width of the rectangle, or the length of the rectangle? The length of the, first, what is the area? The area of the rectangle, right? Area of the rectangle is equal to length times width, let's say, or width times height, whatever. This width is from this point to this point. If this is minus x, so this is x, and this is another x, so the width is, the length is double x, right? The length is double x. That's great. And how much is the height of this rectangle? What is the height of this rectangle? This rectangle, we don't know how much is this height. We know that exactly the width is double x, because he told me what two vertices are x and x, minus x and x. But the height will it might take all the parabola up to here, right? It will take all the parabola till the end. So the height of the rectangle, or the width of the rectangle, it will be the width of the rectangle up. It will be, let's say, height of this parabola from 0 to this point. So it represents the minus x squared plus 1, which is the equation of this parabola. All right. Now let me find the f of x. F of x will be the length, which is 2x, into the width, which is minus x squared plus 1, right? Minus x squared plus 1. This is minus over here, x squared plus 1, and that will be equal minus 2x cubed plus 2x. Okay, fine. Part A, right? Part A, we have to find f of half. So we just substitute half. It's negative 2 into half power 3 plus 2 into half, and that will give me 1 over 8 times minus 2. It's minus 1 over 4 plus 1. So the answer is 3 divided by 4. Part B. Part B, he says, he wants me to do what? Let's see. Part B, he wants us to, what is the greatest value of f of x, of this area? Greatest value of this area. This means I'm maximizing this area. The maximum area we can get. Simply, we derive, right? We derive this f of x. We will get minus 8x, or sorry, minus 6x, right? It's minus 6x squared plus 2. By this is the derivative. Okay, we can take 2 common into minus 3x squared plus 1. Taking this derivative equal to 0, we will end up with negative 3x squared plus 1 equal to 0. This implies that x squared will be equal to 1 over 3, and that is x equal minus radical 1 over 3, which is minus radical 3 over 3, but this minus radical 3 over 3, right? By rationalizing, this does not belong to what? To the interval 0, 1, because he gave me from the beginning that we are working on under this interval from 0 to 1. So this value is rejected, and or x could be equal to radical 1 over 3, which is radical 3 divided by 3, which belongs to 0, 1, and this value is accepted value, and this value is rejected value. So x should be this value. That's great. We have f of 0. We can substitute 0 instead of x, right? Over here, this is the area. It will be 0. If we substitute 1, also we are going to get 0. But if we substitute this value we got here, which is radical 3 over 3, we got what? Minus 2 into radical 3 divided by 3 cubed plus 2 times radical 3 divided by 3. And that will be minus 2 multiplied with 3 radical 3 by 27 plus 2 radical 3 divided by 3. And this will be equal to minus 2 radical 3 divided by 9 plus 2 radical 3 over 3. Okay, let me multiply this and this with 3. We got minus 2 radical 3 over 9 plus 6 radical 3 over 9. Final answer will be 4 radical 3 divided by 9. 4 radical 3 divided by 9 is the greatest value of f of x. So I maximize the area of this. The maximum possible area I can get is 4 radical 3 over 9, whatever, centimeter squared, if we are working in centimeters.